Hello students, welcome to the next lecture on the numerical analysis. Today we will discuss about a Regula Falsi method for finding the root of the function f of x is 0. I will explain you the several examples related to the 10 to 12 in this lecture so that you can understand it very well. Myself Dr. Harish Garg. You can simply follow my YouTube channel where you can find the various lectures related to the numerical analysis and its MATLAB code. We have described the bisection method, MATLAB code, Regula Falsi method, the MATLAB code we already explained that. Also there are the several complete list of the numerical methods available in this playlist. So as I told you in our last lecture we have discussed about the theory lecture related to the bisection method, which is one of the iterative method for finding the root of the equation f of x is 0. In this lecture we will see how you can find the root of the equation by using the Regula Falsi method. Remember, all these methods are applicable for the algebraic as well as the transcendental equation. In all of these methods, that is for finding the root of the f of x is 0, the principle behind all these method is intermediate mean value theorem. What is suggested you, if f is any of the real valued continuous function of the closed interval such that the value at its endpoints are of opposite sign, then there exists at least one root in between the a comma b such that f of a is 0. Make sure this is at least one root, so it is always in the form of the odd number of the pairs, because it is at least one number of the roots, but it can never be 2 because 2 is my even number. It can never be. So whenever it's a greater than equal to 1, it's 1, 3, 5, 7. Why it happens so? As I explained you earlier in my bisection method. You can watch about this lecture. Now the Regula Falsi method is again used for finding the root of the equation with the property of the intermediate value theorem. So it is similar to the bisection method, but the only difference is it applies the different strategy to find the new root or estimated root. Now since it is given that f of a into f of b is less than 0, so I assume that f of a is greater than 0. So because here are the two cases, either f of a is less than 0, then f of b is my greater than 0, or you can say f of a is greater than 0 and f of b is my less than 0. So both the approaches are the similar. These are the same approach. So I assume this is the case as here. So what is the meaning of that? F of a is positive, so it means this is the f a, this is my f of a, this is the b, this is the f of b, and these are the coordinates of the point p and q. Now what is the bisection method told you? If you have the interval a comma b, you can take the midpoint of this, say x0, where x0 is my midpoint of this, and then look at the value, this is negative, then again you can take the midpoint of a and x0, which is I called as a x1. So say this is my midpoint, this is x1, then take the midpoint of x1 and x0 and so on. So you created a sequence xn, which is x0, x1 and then so on, until you will get a required root of this or up to desired accuracy. While in this bisection, this is the bisection method, while in case of the Regula Falsi method, instead of taking the midpoint, we can join this code, that is a PQ. We can join this equation points P and Q through the line joining a straight line. Then this point, this is the called as the new root. How you can find this new root? That clearly says, if I, what is that? This is the intersection of, what is that? This is the intersection of this line PQ with the x-axis. That is the meaning of this. Because once it will here on the x-axis, we can say y is equal to 0. So the intersection of this line with the x-axis represents the improved estimate root. Again, if I take this and b, then we can see the new point here. Then we can join these coordinates here. Then we get a new point, and then again until we will get near about this root. How you can write the equation of the PQ? That's a simple 2-point equation form. Now it cut on the x-axis, so it means y is equal to 0. So I can substitute here as y is 0. So from here, can you find the value of the x? You can easily see this is the b minus a f of a divided by fb minus fa, which is x minus a. So can you find the value of the x from here? This is a minus b minus a f of a divided by fb minus fa, or otherwise you can simply you can take the LCM, and after that you will get this is the required expression. This is the value of this new root. Now what I told you, after that you can see again this value is negative. So now you can join this line, and then now this is again new root by taking this formula. Again you can join them, again you can take this, and you will get this required root near to them. Now how you can find the root of this? What is the algorithm behind that? So first of all, this Regula Falsi method is also called as the linear interpolation method. It is also known as the chord method. Why we call as the chord? Because as you can see, I can join the equation of, what is the equation of this is? This is nothing but my equation of the chord. Or it is also called as the false position method. What is the algorithm is? This is that you can see either you can assume f of a less than 0, or you can assume f of a greater than 0. Both way you can solve this problem. There's no problem about that. Then we have the 3-step approach. What is the first step is? You can find the new root by using the equations of this on the interval a comma b. Then we can check at this new point what is the function value of fx, whether it's a greater than 0 or it's a less than 0, depending upon that. If it is a greater than 0, then we can think about the b, because it's a greater than. If it is a less than 0, so less than 0 is my a, then we can think about the a here. So if f of a is greater than 0, that means this condition hold, then we can replace this b with the x here. So now the interval will be my here. On the other hand, if my fx is less than 0, that means we are thinking on the a, then we can replace the interval a with the xb. Now once you can find this new interval, then again we can apply here, and we can check about the stopping criteria. If the difference between the two consecutive new solution is less than of the desired accuracy, then we can say xk is the root. Otherwise we can found this new interval, new solution for here, and then we can proceed. Remember that instead of this is the absolute error. You can use the relative error as well, depending upon your requirement. So let's see, we will explain you the 10 to 11 examples in this lecture so that you can understand it very well. So remember, we will explain you a very simple approach again with the help of the shortcut ways, so that you will get a right answer without much error in your examination. So find the real root of this, which is nothing but the algebraic equation, by using the Regula Falsi method up to the 4 decimal places. So what is that? F of x is given to you. Now first of all, you can think about whether the interval a comma b is given to you, in which the root lies. It is not given. So once it is not given, then you have to apply this intermediate value theorem, so that you can find the value of f of a and f of b, where the one value is either less than 0 and second value is greater than 0. So clearly says, if you take f of 0, what is the f of 0? Is a 1, which is greater than 0. If you take f of 1, what is that? It is 1 minus 9 plus 1, which is minus 9 less than 0. So we get the two values 0 and 1, which are of opposite sign, that is f of 0, f of 1 is less than 0. What is the meaning of that? It means the root lies between them. Fine. So you can see, or because you can see the 0 1 is also the root lies between them. Also you can see f of 1, if you find the f of 2, which is greater than 0. That's on your choice, because there are the three roots. You can find the root either between 0 and 1 or between 2 and 3. That's on your choice. So let's say I can find the root between 2 and 3. So that means they are opposite sign. You can here. Remember, as I told you earlier, because what is the f of 0? Is 1, which is greater than 0. F of 1 is my, if I take a 1, it is my minus of 7, which is less than 0. So therefore, one root is also lies between 0 and 1. That's on your choice whether you want to proceed on this side or on this side, because there are the three roots. So one root is lies between 0, 1. Second root is lies between 2 and 3. Also you can find some another root as well. So now we have to find the error up to the 4 decimal places. Remember, as I told you in the bisection method, error is always be 10 raised power minus n, where n is the number of decimal places, your required decimal places. In this case, n is my 4, so you can see n is my 4. So after this calculation you will get here. What is the meaning of that? You can find the difference between the two consecutive root. If it is a less than or equal to this number, then we can stop the process, otherwise not. Then whenever you are working on the regular falsi method, we can draw this table. Now the roots are lies between 2 and 3. Fine. What is the value of the 2 f of? It's a negative. You can choose as a sign of this. What is the value of the 3? It's a positive here. This is only for the sake of simplicity. Fine. Now you can substitute the value here. What is that? A is my 2. What is the f of b? B is my 1 minus b. B is my 3. What is the f of a? Minus of 9 divided by f of b minus f of a. Fine. So once you will solve, you will get the expression as 2.9. Now substitute this value of 2.9 here. What is that answer of this? You can get as 2.9 cube minus 9 into 2.9 plus 1. So after the calculation you will get the result as here. Now since there is no previous value, so we can return as a high one. Now look at this shortcut approach. Since this is a negative number, so here is a negative, so I can replace this number with the negative sign 2.9, and this number I can take as such. Remember, this is a negative, so that's why we have to replace this as a negative one. Now based on this f of a, this is the f of, this is the a, this is the b, f of b, what is the f of 3 is my 1, what is the f of a, this is my f of a. You can substitute this value and get this is my required expression. So once you know this is my x of k, substitute this value here, you will get this number. How you can compute this number? This is the x2, 2.9416 minus 2.9 absolute value. So clearly say it's a 0.0416. Now is it less than of this? Is it less than of 0.0005? You can see, is it less than of this? No. So then we can move on this third step. Now clearly say this number is my negative, so I can replace this negative, this value with the negative sign, and this number as such. Fine. Now again you can get a, you can get as a b, so you can substitute this value here, you will get this answer. Substitute this value again in this case. You can use your scientific calculator so that you can get your answer in a very simple. Remember in your scientific calculator, there is the option of that table. You can use this table and then create this value in a very simple manner. How you can calculate this value? This minus of this. If you take the difference of this, you will get this number. Again, this number is not less than of this number, then we can find the fourth value. Again, this number is my negative, so I can replace this number with the negative sign. If this number is positive, then we can replace the positive numbers. So if the positive number is remain same, we can compute it as here. Now clearly say this number is less than of this number. Yes, so we can stop the process, and the final answer of this is my here. Now we need a 4 decimal places. We can round off up to the 4 decimal places. You can get up to the desired root as here. So I hope you can simply learn. Now you can see the various examples based on the same trick. Now you can see this is my transcendental equation because it involves this exponential part. Again, the interval is not given to you, so we can start with the f of x. We can find the firstly a comma b interval. Clearly says what is the f of 0? It is minus of 3, which is less than of 0. What is the f of 1? You can see it is e minus 1, which is again a negative. What is the f of 2? It's a 2e square minus of 3. So what is the e is? It's a 2.718. If you take 2 times e square minus 3, it is greater than 0. So these two numbers are there. So it means the root lies between, what is that? Root lies between 1 and 2. You can also say the root lies between 0 and 2 because it's a negative, it's a positive, but the length is very large. You can see the length is 2, but here is the length is 1. Always take as much as smaller length you can. Like here, you can see f of 2 is my positive. You can check in between them also so that your calculation will be less. So I can see 1.5 is a greater than 0. So it means the root lies between 1 and 5. Remember, you can also check like this, f of 1 is negative, f of 2 is my greater than 0. So you can also see the root lies between 1 and 2. But you can see the length of this is larger than of this. So this step will take large number of equations. It will take the large number of the equations, while this has a small number of the equations. So like say, if I say this will get a 4 equations, then it definitely contains at least 7 equations here. Now we have to need the up to the 3 decimal places. So it's a half into 10 raised power minus n. N is my 3. Now we can take the table. So 1 and minus 1 and 1.5. 1 is my negative, so we can take as a negative. 1.5 is a positive, we can take here. Substitute this value here, we can get this value as of this. Now we can substitute this value here, we can get this value as this. Since this is a first value, so there is no error. Because this is a negative sign, we can compute the second step. This is a negative sign, we can replace this value with the negative sign and this number as such. Now once you can repeat, now this is the A, this is the B, we can substitute here value. This is my f of A, this is my f of B. We can substitute, we can get this number as such. How you can compute this number? I can substitute this value at here. How you can compute the error? It is nothing but 1.0456 minus 1.0352. That is a difference of these two consecutive numbers. Absolute value. You can see this is 0.014. Clearly say this is not less than of this error. So we can compute this third number. Now again this is a negative number. So we can replace this number with the negative side. Here this is a negative. And I can see this number as such. We can compute here. Now again you can see the difference is now the difference between these two consecutive terms. Again this is not less than of this number. We can compute this fourth number. Again this is a negative number, so we can replace this value with the help of here. So then we can compute here. Again you can see this number is not less than of 0.0005. We can compute the fifth iteration. Again this is a negative, so we can replace this number as here. Then we can compute here. Now you can see this number is less than of this number. So we can stop the process, and this is the required answer. You can convert into the 3 decimal places. You can write it as here, or you can see up to the 3 decimal places we can write. Remember that now I have taken the interval as 1 and 1.5. So how many steps you have needed? You take a 5 equations. But we also saw that the roots are lies between 1 and 2 also. So then if 1 and 1.5 lies the 5 equations, then definitely it will take the 8 equations at least 8 equations. So that will take a larger steps you have. So always try to make the interval as smaller as you can. Okay, find the third question. So again the interval a comma b is not given to you. Then we can start from here. You can see f of 0. F of 0 is my e raised to power 0 is a minus 1, which is less than 0. If you take f of 1, what is that? It's a 3 plus sine 1 minus of e. So clearly say this number is my 2.718. This is 3 minus 2.7 is a positive. This is the positive which is greater than 0. So therefore root lies between 0 and 1. So you can also check whether there is any other number. You can see I can take as a 0.3. Then we can check about the 0.4, whether it's a less than 0 or greater than 0. So we can see, we can find that it is a greater than 0. So we can see the lies between 3 and 0.3 and 0.4. Or you can see f of 0 is less than 0, f of 1 is greater than 0. So you can see the root lies between 0 and 1. So definitely you can see the length is very large as compared to this. So it takes less iterations than of here. Now in this case you can see there is no given that how many decimal places you needed. Is that given that? No. So if nothing is given to you, then by default the number of the decimal places you need to calculate it as 4 if nothing is given to you. Fine. So then you have to correct up to the 4 decimal places, half, 10 raised to power minus 4. Fine. Now you can take the table 0.3, 0.4. 0.3 is a negative, so you can take a negative and positive. Substitute this value a, b, f of a, f of b here, you will get the value of x, this one. And substitute this value here, you will get this. Remember, one important note is when you are trying to calculate the value of the sine 0.3, fine, when you want to calculate this value, make sure you have to set the values in the radian in your calculator. Fine. Remember, when you are using your scientific calculator, set the radian angle when you calculate the sine or cosine or tan. Any trigonometric function you can set as a radian. Now you can see this value is my positive, so I can replace this number with the positive sign b. So that is 0.3612, and this value I can preserve as such. Remember, if this is negative, then we can replace this value with a negative. If this is a positive, then we can replace as a positive sign. Now based on this a and b, we can substitute this value and compute here. And once you substitute this value here, you will get this answer. Clearly says this number is not less than of this number. Although f of x is almost 0, but the error is not less than of this. Then we can find the third number. Since this is a negative number, so we can replace this number with a negative sign and this number as such. This number is my as such and this number is my here, and we can count it. Now clearly says this number is less than of my here, then you can get the required answer as here. You can convert into the 4 decimal places, you will get is the required answer. Now clearly says that I have taken the 0.3 and the 0.4 so that it takes the 3 iterations only. But if you take the interval as a 0, 1, so definitely it takes more than 7 iterations to get your right answer as here. Okay, look at this another one. Now again you have to need the 4 decimal places by using the false position method. That's a Regula Falsi. Again this is a sine and cosine term, so you have to set your angles in the radian form. So let's say now clearly says f of 0 is my 6, is a positive number. F of pi by 2, because cos pi by 2 is my negative. When you substitute here, it's a cos pi by 2 minus 3 times pi by 2 plus 5. So it's my 0. Remember, this pi is my 3.1415 and so on. It is not be the 180 because it's a x. So it's a 3.14, or you can say 22 by 7. So once you substitute, it's a negative. So what is that? 3.1415 divided by 2, which is nothing but here. So the root lies between these two numbers. Up to the 4 decimal places you can write up to here. Now you can start with the table. F of 0 is a positive, so you can see 0 is a positive, b is my negative. We can substitute this value in this table. We can find the value of the x and here. Clearly says this number is my, I can substitute this value here, this number at here, you will get this number. This is my positive, so I can replace this value at positive, sorry, this is my positive, so I can substitute this value, replace this value positive here, and this value as such. We can, now we can substitute these two values at here, we can get the new value of the x, and here. This error we can take the difference between them. Clearly say this is not less than of this number, then we can move on the third iteration. Again this number is positive, so I can replace this number with the positive sign. This is positive and this number I can replace as such. Then you can clearly says that this number is less than of my this number, so we can stop the process, and this is my right answer. We can convert into the 4 decimal places, which is the required desired root up to the solution. Look at this another one. So now it is already given to you that the root lies between 3 and 4. So we just only need to check whether f of 3 is greater than 0 or it is less than 0, and f of 4 is less than 0 or greater than 0. So we can substitute the value f of 3, f of 4. We can write the f function in here. Now you can see it lies between 3 and 4. Now up to the 3 decimal places, your error will be 10 raised to power minus 3. Fine. Now you can construct the table. 3 is my less than 0, so I can say 3 as a negative, 4 as a positive. Substitute this value at this formula, you will get this number. Since the first number is negative, so I can replace this first number as here. Fine. Remember, whenever you have to find the 3 decimal places, write up to the 5 here. If you want to write in the 4 decimal places, write up to the 5 or 6 decimal places, so that at the end of the answer you can round off that. Now clearly says the difference of this is my here, which is not less than of this number. Then we can move on the third step. This is a negative number, we can replace this number as here, and 4 I can say use as such. Now you can see this number is less than of this error, so we can stop the process and we can convert this into the 4 decimal up to the 3 decimal places. You will get the required answer as here. Look at the another one. Again, this is a sine and cosine form, so you have to use in terms of the reading. Now up to the 3 decimal places, but again the interval a comma b is not given to you. So we can see f of 0, sine 0 is 0, it's a negative. If I start with the f of 1, it's my positive. Fine. Or f of 0.5 is also positive, because our target is to make the number as small as possible. Or you can see f of 0 is negative. You can also see f of 1 is greater than 0. So you can take as a root lies between 0 and 1. But here you can see the length is large, so you have to take a more number of the iterations than of this method. Now you have to find up to the 3 decimal places, so the error will be here. So we can write here. So since f of 0 is negative, so I can take as a 0 negative, 0.5 positive. We can find the new value here, and then since this number is positive, so I can replace this number as a positive sign and this number as such. So we can write here. Now substitute this value in this given function, we will get this here, and this number we can take as a difference of this number. Clearly says this number is not less than of this number, then we can move on this third step. Since this number is positive, so we can replace this value as a positive sign, this number as such. Again you can see this number is not less than of this number, then we can move on the fourth step. This number is my positive, so I can replace this number by again here, and negative I can preserve that. Now clearly says this number again is not less than of this number, then we can move on the fifth iteration. This number is my positive, so I can replace this number here, this number to be this number. So and so on. Again you can see this number is not less than of this error, this number is not less than of this error, and this number you can see is less than of this error. So we can stop the process, and you can see this is my required answer. You need to convert into the 3 decimal places. You can see after rounding of them, you can write into 3 decimal places. Okay, look at this another one. Find the real root of this up to the 4 decimal places. F of x is here. Now clearly says f of 1. What is the log 1 is 0. It's my here. Fine. So you can find the another number also, or because f of 1 is my less than 0. If you find f of 2, which is also less than 0. If you find 3, then it is a greater than 0. So clearly says the root lies between 2 and 3. Or you can also say the root lies between 1 and 3, but you can see the length of 1 and 3 is larger than of 2 and 3. So I prefer 2 and 3. Now we can construct the table. The value at 2 is my less than 0, so I can take as a negative. This is a positive. We can find this value here. Now this number is my negative, so I can replace this number as negative values. Find these two numbers, we can substitute here. We can find the error by using the subtraction. We will get here clearly say this number is not less than of this. We can start with the third step. This is my negative, so I can replace this with the negative sign. So this number as such, I can find this next pair. You can see this number is again not less than of this number, although f of x is almost 0. So but the difference between their error is not less than of this. So we can see this is a negative number. Now you can replace this number as here and this number as such. Now clearly say this is my less than of this. So we can stop the process, and this is my required answer of this. You can write up to the 4 decimal places. Look at one more angle. So this is again cosine, so you can write in the radian form. So f of x is my here. So what is the f of 0? Because this number is 0, cos 0 is my 1, so this is less than 0. What is the f of 1? You can see this is e minus cos of 1. So e is my 2.718. This number is always lies between 0 and 1, so which is a positive number. Or you can check about in between them. You can see 0.5 and so on. So but you can check here, or you can check 0.5 as well. If it is a greater than 0, then you can find the root between 0 and 0.5. If it is a less than 0, then you can take the root lies between 0.5 and 1, so that you will get a less number of the equations. Now again the 4 decimal places are there, so your error will be this one. Now we can substitute here. So it's a 0 and 1. So 0 is my negative, positive is here. Now you can substitute this value, you will get this as here. Since this number is my negative, so I can replace this number as here negative and this number as positive. Now you can see this number is not less than of this. We can find the next equations, and this is a negative, so we can replace this number as here. Again this number is not less than of this number, so we can proceed. You can move on that. You can see up to here, which is again not less than. You can see now finally you can see this error is less than of this number, so we can stop the process, and you can see this is my right answer of this problem. So you can see that instead of taking the you can see I have taken the 0 1 interval. Length is very large, so that's why we need a 10 equations. If you take the 0.5, you can see again it's a negative. Then instead of the 0 and 1, you can take the intervals 0.1, 5 and 1, and you can see within a 3 to 4 equation you will get the right answer in a very simple manner. So that's the simple way you can solve this problem. I hope you can simply remember this Regula Falsi method in a very nice manner. We will see the next lecture on the fixed point equations. Till then, you can simply like, share and comment on my video. You can share with your students, friends and colleagues. Best of luck students. Happy learning.